Okay, this topic is preparation of haloalkanes. From which compound we can prepare haloalkanes and by reacting which reagents. Okay, this is the topic we are going to do now. First of all, we can prepare haloalkanes from alkanes by substitution reaction, free radical substitution reaction. The name of the reaction is halogenation. This is a free radical substitution reaction. Free radical substitution. So we are taking an alkane here. This is R. R is alkyl group. Alkyl group is formed by removing one hydrogen from alkane. So I am again keeping that hydrogen. So this becomes alkane. This is alkane. R, H is alkane. R is alkyl group. H is hydrogen. When this is reacted with chlorine or bromine in presence of light, or this reaction mixture can be heated at high temperature, then this hydrogen is substituted by one of these chlorine atoms or bromine atoms. So we will get RCl, one hydrogen and one chlorine combined to form hydrogen chloride or hydrogen bromide. This can be bromine also, right? So this is our haloalkane. RCl is haloalkane. We can take example. First example is, this is our methane. Methane can be written as CH3H in this form. Okay. So when this methane is reacted with chlorine in presence of light, then one of the hydrogen atoms will be substituted by chlorine atom. So we will get CH3Cl plus one H and one Cl combines to form HCl. This is our methyl chloride or chloromethane, we can say, right? This is methane. Methane is an alkane. This reaction continues. This is a chain reaction. If we react this chloromethane with chlorine again in presence of light, then one hydrogen will again be replaced by chlorine. So we will get CH2, one hydrogen goes out, and one chlorine will come in to form this dichloromethane. This is dichloromethane, right? And again, if this is again reacted with Cl2 in presence of light, one hydrogen will be again replaced by chlorine to form this CHCl3. CHCl3 is trichloromethane, which is also called chloroform. Again, this can be treated with chlorine in presence of light to replace all the hydrogen atoms present to form CCl4 plus HCl. CCl4 is carbon tetrachloride. The reaction continues in this way. So in the exam, only the first step reaction, this is important, right? No need to write the chain reaction. But if someone asks to form chloroform, then you need to write this reaction. Okay. Another example is, I am taking ethane and this is reacted with chlorine or in presence of light. Then one of the hydrogen atoms from these two carbon atoms will be replaced by chlorine, and these two carbon atoms are exactly same. So substitution can be done to either of these carbon atoms, right? So we will get CH3, CH2. This hydrogen is to be replaced by one chlorine atom. So we will get chloroethane plus HCl. This is byproduct. This is not important to write. Okay, only the main product is important. This is chloroethane. This is ethane. This is chloroethane. Chloroethane, or you can write ethyl chloride. Chloroethane. Now, if I take these two carbon atoms are exactly same, so we get only one product here. This is byproduct. Okay. If these two carbon atoms are different, then we would have got two different products. For example, I am taking this alkane now, CH3, CH2, CH3. This is propane, and all the three carbon atoms are not same here. Here these two carbon atoms are exactly same, but here this carbon atom and this carbon atom are same, but this is a different carbon atom. These two are primary carbon atoms. This is a secondary carbon atom. So we have two different carbon atoms here. Accordingly, when chlorination is done in presence of light, substitution can be done either to this carbon atom or to this carbon atom. This and this are same. So we will get two different alkyl halides. The first substitution is from this carbon atom. One of these hydrogen atoms is substituted by chlorine to form this product, and another substitution can be done to this carbon atom or to this carbon atom. So we will get CH3, CH2 to this carbon atom, CH2, Cl, like this. So we have two different haloalkanes here as the product. Byproduct, I am not writing the byproduct. Okay. So number of monochloroalkanes formed will be equal to number of different carbon atoms present in the alkane. Okay, that is number of different carbon atoms present in the alkane will be equal to number of monochloro or monohalo, you can write, alkanes formed. Alkanes formed. No doubt. So here we can take another example for halogenation of alkane. Suppose we take this alkane. This is 2-methyl propane, or also called isobutane. Isobutane, and this is reacted with chlorine in presence of light. How many different carbon atoms are present here? This carbon atom, this carbon atom, and this carbon atom. These three carbon atoms are exactly same. They are primary carbon atoms and their surroundings are same. And this is a tertiary carbon atom. This is a different carbon atom, to this carbon atom 3 carbon atoms are directly attached. This is a tertiary carbon atom, while these 3 carbon atoms are exactly same. They are primary carbon atoms. Okay, now when chlorination is done, since we have 2 different carbon atoms, we will get 2 different monochloro products. So first of all, this is the product. Substitution is done to this carbon atom. CH3, CH2 is left, and one of the hydrogen will be displaced by chlorine. This is one product. Okay, and another product will be obtained by substituting this hydrogen by chlorine, right? So this will be the second product, CH3C, CH3, CH3. This hydrogen is to be substituted by chlorine. These are the two products because we have two different carbon atoms here. Now, one important point here is when this isobutane is reacted with bromine in presence of light, we will obtain such two different products. Here in place of chlorine we will get bromine because we are reacting this alkane with bromine. Another product is this one. Right, these are the two products. Now the important point here in these two reactions is in chlorination, this product which is obtained by substitution to the primary carbon atom is major product. This is major product and this is minor product. Major, minor means what? In this reaction, amount of this product is obtained in large quantity, right? While this is obtained in less quantity. While in bromination, this is our major product. This is our minor product, right? So here reactivity of hydrogen, because hydrogen is being substituted in this reaction, so it is good to know the reactivity of different hydrogen atoms, reactivity of halogens. Okay, so this, note down this reactivity order of halogens for this particular reactions is fluorine is very reactive, which cannot be controlled actually. Fluorine is far reactive than chlorine, is again more reactive than bromine, is again very reactive than iodine. This is very reactive fluorine, so the reaction between alkane and fluorine cannot be controlled. And this iodine is very less reactive. Okay, so we usually avoid these two halogens, and so chlorination or bromination is there. Okay, another reactivity order is reactivity order of hydrogens, because substitution of hydrogen takes place. So which hydrogen is more reactive, that is important to note. Okay, reactivity order of hydrogens. So tertiary hydrogen, 3 degree means tertiary hydrogen, okay, is more reactive than secondary hydrogen, is more reactive than primary hydrogen. You can note down this reactivity order. Actually this major product here in chlorination is the product which is obtained by substituting hydrogen from the primary carbon atoms. Here larger number of hydrogen atoms are present. Okay, this chlorine is very reactive and this is less selective, so substitution is done to the carbon atom where larger number of hydrogen atoms are present. While in this case bromine is less reactive, means this is more selective. Less reactive means more selective. This can select actually. The mechanism, this actually can be done through mechanism, but I am not doing the mechanism here because in your syllabus mechanism of this reaction is not there. This was studied in 11th standard. Okay, and this chlorine is more reactive means this is less selective. So this is based, these two products are based on this point. You just can say why this is the major product, this is the minor product, or in this case why this is the major product, why this is the minor product. You just can say in case of chlorination, chlorine is less selective, while in case of bromination this is more selective. Okay. Next, this is about halogenation of alkanes to prepare haloalkanes, right? Second reaction, let us go to the second reaction. The second reaction is preparation of haloalkanes from alcohols. Okay, second one is from alcohols. Okay, alcohols are generally represented by ROH. R is again the alkyl group, OH is the functional group of alcohol. Okay, when this alcohol is reacted with SOCl2, or you can write SOBr2, or you can write PCl3, or you can write PBr3, right? Or you can write PCl5, like this. There are so many reagents to convert alcohol into haloalkane. Alcohol, this is alcohol. So when this alcohol is reacted with these reagents, you can take any one of them. If you want to prepare bromoalkane, then you must take these reagents, and if you want to prepare chloroalkane, then you can take these reagents containing chlorine. Okay, so ROH will be substituted by OH will be substituted by chlorine, or you can say bromine. So this will be the product. Among this reagent, this or this, okay, this two are same. This is called thionyl chloride. Thionyl chloride. SOCl2 is called thionyl, or this is thionyl bromide. Okay, thionyl chloride. This thionyl chloride is the best reagent to prepare chloroalkane from alcohol. Question can be asked, why? Let me give you example first. Then I'll tell you why this is the best reagent. Okay, so ROH, R is alkyl group, so we can take ethyl alcohol. This is ethyl alcohol, ethanol, major constituent of the alcohol which are being consumed by some people. Okay, ethanol, when this ethanol is reacted with SOCl2, this OH will be substituted by Cl. This SO and this O combine to form SO2. SO2 is what? Sulfur dioxide. One hydrogen and one chlorine, HCl. These two byproducts are, in this case, obtained as gases. So they vaporize, okay, they go out from the reaction mixture. So we obtain the haloalkane in pure form. Only we obtain the haloalkane in pure form. So therefore, this thionyl chloride is best reagent to prepare haloalkane from alcohol. This is our ethanol. This is our ethyl chloride. Ethyl chloride, or you can say chloroethane. No. So here we can take another example to prepare haloalkane from alcohol. This is the first example. Second example is CH3CH. Suppose this is an alcohol, its IUPAC nomenclature is 1, 2, 3, 4, right? So this is butane, E is to be removed, 2 ol. Okay. When this is reacted with either PCl3, you can write PBr3, okay, PCl5, or SOBr2 or SOCl2. I am reacting this by, with, for example, Pr3, then this OH is substituted by Br. So we obtain 2-bromo butane. Right. We can take another example in the form cyclic compound. This is suppose an alcohol. There can be double bond also. This is called 1, 2, 3, 4, 5. This is called cyclopent. 2 in 1 ol. This is the IUPAC name of this alcohol. Okay. When this is reacted with, you can write PCl3, PCl5, whatever you can write. Okay. Any one of them. There are other reagents also other than this that can be used to prepare haloalkane from alcohol. Okay. Lucas reagent is there. Many reagents are there. Okay. This OH is substituted by, this is Cl. Okay. This one. What is the IUPAC nomenclature of this halide? One is to be numbered here 1, 2, 3, 4, 5. So this is 3-chloro because alkene is given priority over halogen. Okay. 3-chloro cyclopent 1 in. This is IUPAC name. Okay. In this way we can prepare haloalkanes from alcohols. So let me write the point here. Among the reagents, just write in short form. SOCl2, thionyl chloride, that is SOCl2, or it can be bromide also. Okay. Thionyl chloride is the best reagent, to prepare, this is important, can be asked in the exam. Okay. Thionyl chloride is the best reagent to prepare haloalkane from alcohol. It is because the byproducts obtained during this reaction are gases and we get the pure haloalkane. It is because the byproducts bracket SO2 and HCl are gases, and so we obtain the pure haloalkane. Our gases means they go out. They will go out to the atmosphere. Okay. Obtain the pure haloalkane. Note down this. Let us end today's lecture here. Okay. Thank you.